Hey everyone, welcome back to Tech Junior Tutorials. My name is Lee Warwick Jr. and we are doing Advent of Code. We're going to be talking about day 24 today. It's the 27th, so I'm almost done with this thing, a few days behind, so not too terrible. Let's dive into it. So here's the website. You can see I've got all the stars except for day 25. But we're going to be talking about day 24. It is Planet of Discord. Awesome band name. Just want to throw that out there. But we are talking about bugs. So the puzzle input for this one is actually something that looks very similar to this. If we scroll down, you can pull it up all the way at the bottom. So there's the puzzle input. That's all there is to it. So deceptively small input. Is that bad? Is that good? It is. This actually isn't a bad puzzle. So, digging into it, what they are saying is you've got a input, right? It's a 5x5 grid, and the hashtags are bugs, and so they are forcing you to study. I forget what the hook for this one is. Basically, like observing this planet, Eris. A dwarf planet? Kind of cool. So you're observing this planet for its life forms. And so you're looking at bugs, and you're looking at whether the bugs like live or die minute to minute. So they say that you start with some initial state. The hashtags are bugs, periods are just empty space, and the bugs live and die based on some rules. So for every given space, it's like that one, it looks to the, well, let's say we're in the center. So you can look right, left, down, and up. And what happens to this space depends on how many bugs are in the surrounding space. If you're in the corner, you've only got 3 spaces to look at. So for this position, which would be like x is 4, y is 0, so 4, 0, you got actually 0 bugs that are around you. So they say that a bug dies or becomes an empty space unless there is exactly 1 bug adjacent to it. And an empty space becomes infested with a bug if it is surrounded by exactly 1 or 2 bugs. So they give you this starting state in the example, and they recompute the space or the grid after 1 minute. So for every place it looks and sees, so this one has exactly 1 bug adjacent, so that will become a bug, and indeed it does. Down here, this space has no bugs, so it should stay empty. It does. This space also has 0 bugs, so that stays empty. This space has 2 bugs, so that should get a bug, which it does. And this corner space has no bugs, so it becomes empty, which it does. And the same for all these rows beneath it. So if you go through this for like each iteration is a minute. So after 4 minutes, you should end up with this. So really good test data right off the bat. Very clear, explicit rules. 2 rules to follow, basically. So this one obviously is not a modular math thing or a Stack Overflow thing or a data structure thing. This is almost purely a logic puzzle, which is kind of neat. Once you get through all that, part 1 is a little bit different from part 2. Part 1 asks you about the biodiversity rating. So it's going to ask you to calculate the value of this grid, basically. And so what they say is the tiles from left to right, top to bottom, each one is worth 2 to the power of like its position, basically. So like if this is 0, be 2 to the 0, which is 1. This would be 2 to the 1, which is 2. 2 to the 2 is 4. 8. I think 16, yeah, gotta cheat, 32, and so on. So basically by the time you get down here and here, that's 2 to the power of whatever position that is, And so that should be like, so 2 to the 16th, 2 to the 22nd. So that number plus that number gives you a biodiversity rating of that. So just to add a little more spice to it, right at the end, they say, what is the biodiversity rating of the first layout that appears twice? So they don't tell you have to run this a certain amount of times. They just basically want you to run this until it repeats itself. So let's check out my code for this. Again, there is the input. That's the sample input, just for reference. But here is the code for this one. So we parse this just like we have for almost all the other puzzles with open. I went ahead and created a bug grid. I've got 4 line and lines. Go ahead and append that line to the grid. For the state, I'm using a set, which I've used, like, sets have saved my bacon so many times in advent of code. Like, I will never forget what a set is or what it's for after doing advent of code for 27 days now. I've got a little helper method to print the grid. And then from there, basically I've broken down this problem into a couple of different functions. I've got a function that converts the grid to a string. So this is just going to take every line in the grid and append it to each other line. So it starts with a blank string, and that's going to take line 0 and make that a string, and then append line 1, 2, 3, 4, 5. Or, yeah, there's 5 lines in the grid. So all those lines get appended into one string. And I add that to a set, and voila, that's a unique value. So again, sets, super important, super useful for advent of code. So beyond that, I've got a function to calculate the amount of bugs. So start with 0. Go ahead and grab the width and the height of the grid. I didn't know what was coming in part 2, so I went ahead and left a lot of this configurable and not hard-coded. So I grabbed the top, bottom, left, and right coordinates. So top is going to be y minus 1, bottom is going to be y plus 1. We look at the input. So this is a y of 0 at the line 1, and line 2 is going to be y of 1. So if we're looking above it, if we're on line 2, that's going to be y minus 1, it should be a y of 1. So I do the top, bottom, left, and right. I loop through those coordinates, and I say if x is greater than -1 and less than the width, so if it's between -1 and 5, it's 0 through 4. Same for y, between the height. Then look in that spot, and if there's a hashtag, then count that as a bug. And at the end, return the bugs. So to update the bug grid, so I'm going to create a new grid, which I do here. I use Python list comprehension for that, which is another neat thing that I've kind of had to learn for advent of code. So this is creating an array of periods, and then it is creating an array of arrays of periods. That just creates basically like a blank grid. And then I loop through the x and y values of the current grid that's passed into this, and it's going to call count bugs for every value in there. And it's going to look at that place, so that current xy, and check to see if there is a bug present. So when I first did this, I missed this logic here, so I didn't actually put a bug. Like, I didn't detect if there was actually a bug there and then put it on the grid, so things were a little funky. But then some debugging quickly let me uncover that. So this is basically the rules from the problem. If there is not one bug and there is a bug present, that bug dies. If there is a bug around that bug, if there's exactly one and the bug is there, it lives. And if it's an empty space and there are 1 or 2 bugs, then that is now going to become a bug. So that is looping through each grid and creating a new grid at the end. So if you notice, I was storing these as a list of strings. So I created this not as a list of string, but as a 2D list. And so at the end, I join all of those rows or all those lists into strings and then put them back. So the output gives me again a list of strings. For biodiversity, do another nested loop where I loop over the character in each row, and for each character, I've got an n value that starts at 0. I do pow2 to the n power, and then add that to the rating. So if the bug is there, count that, and then its position is going to be like 0, 1, 2, 3, 4 for the first row, 5, 6, 7, 8, 9 for the second row, and so on. And that'll be the value of n. So compute that, and then add it to the rating, spit out the rating. So that made doing this really easy because they tell you what the value is. So as soon as I fed this input in and then calculated the value, like, no problem. Because this was also they gave you the actual example's repeated value, I was able to use this example to like first verify that my bug changing logic worked and run it, 4 times and make sure I got this. Then I could run my set logic to make sure I could get the repeated one. Yep, it looks like that. And then do the biodiversity and then make sure that this repeated state spits out this number. And from there, like, I knew I had it. So we run this. Gotta add the .py on the end. So there you go. There is the actual repeated state. And that is the value, 257, 19471. So where the rubber meets the road is for part 2 on this one. So if you recall, from days, I know at least 20, they've mentioned some Plutonians a few times. And so in Advent of Code, the Plutonian race is known for recursion. So much like the donut maze where there was a smaller maze inside of each maze, here we've got smaller tiles inside of the tiles. So basically this is the same grid from part 1, except the middle tile is going to be another one of these tiles within that tile. So they give you a really good visualization of this. So here's a not to scale version of this, but so here's 0 through 4, 5 through 9 indices, and they've got a alphabetical grid inside, and so there's an even smaller one in there. They don't say it, but there's an even larger one outside of this grid. So if you come down here to the example they give, again, like, bless them for giving all these example inputs, but you notice that the depth goes negative and positive. So you can go in both directions. You can go outer and inner with the recursion. So they say recursion, but you don't. I mean, maybe technically by definition it's recursive, but you don't have to do any recursive programming to actually get the answer to this. You just have to think recursively, which is kind of scary. So they say that there's the same rules as before, except you're going to get the same starting input. But for the starting input, they say what they gave you here in the middle is intentionally a blank space. And that is a blank space because that space is another recursive grid. And then outside of this, there is another entire grid around it. So they say is that you'll never look at position 2, 2. You will look at another grid whenever you're at that position. And if you are at one of these outer edges, so let's say you're at E in a smaller one, for E, you're going to look at the value in 8 and 14 and see like if there's a bug there. And then also D and J. And then if you are looking the other direction, so if you're in position 14 and you're checking like how many bugs are around 14, so there'll be 9, 15, and 19, but also E, J, O, T, and Y. So you're going to do that for basically like all the grids. So when you start, you just have one, and it is going to have a outer grid that is blank spaces and an inner grid that is blank spaces. So you don't need to check those because they will be 0 bugs. But once you calculate this inner grid, now you need to calculate the outer grid. So, and the inner grid. So basically, like each loop through, you have to add another outer depth and inner depth, or like a max outer depth and a max inner depth to the problem. So whenever you add a new grid, let's say that this outer one is a new grid. So like you would look like obviously 15, 9, and 19 are going to be empty, but if you're going to look at this row here, or column, I guess, if there is 1 or 2 bugs in this side of your original grid, this will become a bug. Same thing for here, you'll look at this row. At 8, you'll look at this row. For 12, you look at this row. And then for your inner grid, it will also have sides touching. So like the entire left side of the inner grid is going to look at L. If L is 1 bug, the entire left side of the inner grid is going to be bugs. So they don't really give that away looking at the inputs, but they do tell you after 10 minutes, like, this is what the state of your grids is going to be if you were to print all of them out. So I did like after 1 minute and just double checked it, because doing 10 is like too much to think through and too much to display in the terminal. So then they get rid of the biodiversity, they get rid of the repeating states, don't care about any of that. So you can delete that code for part 2. But they ask, after 200 minutes, in all of the grids, how many bugs are there? So they say after 10 minutes for this example, you get 99. So that's your lone test case that you can try this against. And if you get that, like, you probably have it, which is great. But the code for this one, it's a lot of code. So here is all of my code. So I managed to keep it to 200 lines. Most of it is similar. Like I said, I got rid of the biodiversity thing, went ahead and deleted that. I deleted the state set and the conversion method for that because I didn't need it anymore. And what I've got instead is a bunch of helper functions. So we can collapse these and you can see just how many helper functions I have. So here is my actual code that is looping over 200 minutes. It's just a for in range loop over 200. And I'm going to have a dictionary of grids, and the state of, well, yeah, the state of each grid is going to be saved to its depth value. So I start at depth 0, and that's just going to be the input bug grid. And then for each one, I'm going to update the grid dictionary. And then at the end, I have a helper method which loops through all of the grids and counts all the bugs. So how do I do this logic? What I did was I looked at this example that they have. I said, okay, for each pass through or each loop over all of the bug grids, I'm going to have to look at the outer grid and the inner grid. And so if I'm computing this one, I'm going to need to look at the outer grid. I want to look at the inside of the outer grid, which is already like hard to think about, right? Already a real brain teaser. So I need to look basically at inner values and then outer values. So like the outer value of this, I want to count everything in that row. How many bugs are there? And then for the inside, I just want to look at this one spot. So I made helper methods to do all of those. So I've got top, bottom, left, right, outer, top, bottom, left, right, inner. And so for my outer methods, I say, hey, if the depth is already created in the grid dictionary, go ahead and grab that grid, start a counter at 0, and then loop over. If we're looking at the outer row, I want to loop over the whole row. So that is this whole row. And check to see if there's a hashtag there, and then add 1. And I do that for all of them, except I'm going to change what row I'm looping over. So in the top, I'm going to loop over row 0. I loop over -1 in bottom because Python will let you grab the end of a list with a -1, which is super handy. And then left is going to loop over columns and look at position 0, or loop over rows and look at position 0, so that'll give me the left. And then to look at the right, I'll look at like the width -1 or -1. For the inner, I'm just looking at a specific point. That's going to be always 1, 2, or x of 2, y of 1. So that is x0, 1, 2, y0, 1, right there. That is the top inner, left inner, right inner, bottom inner. So I do all those methods for whatever depth I am looking for, and all of them will check to see if the depth is in the dictionary, otherwise return 0. So from there, I had to, this is like the really meaty function, but I had to modify my previous function that is actually counting the bugs in any given grid. So it's still doing the same logic from before, except I have basically, because this already ignored the edges, right? So if we're looking at here, like if I'm in this position of 0, 0, it doesn't really care about top and left. It filters those out in this logic here by saying if these values that I've computed are within these ranges, basically within the grid itself. So it doesn't look outside of itself already. I just added a one-liner at the very end that says like, and it is not position 2, 2, because we don't want to compute whatever's here. So I went and changed those to question marks manually. But just in case, I made double sure to make sure not to check that. So then what's left is to look at the outer depth and the inner depth. So for the outer depth, because I'm looking at one point at a time, if I am at x of 0, that means I am in this row. I want to look at the top inner depth. So I'm sorry, if x is 0, I want to look at the left inner. So that means I am in this column. I look at left inner. If I am at y of 0, I would look at top inner. So y of 0, top inner. And then same thing for the other side. So width -1, height -1. And then to look at the inner depth, so I want to basically check here if I'm at that coordinate, that coordinate, that coordinate, or that coordinate. So top middle is x of 2, y of 1. That's there. Bottom middle, 2 and 3, 1 and 2, 3 and 2. So I really tried hard to make this readable, and even though it's a lot of lines of code, I wanted to be able to come back to this and read these comments and be like, oh, okay, that's what I did. So aside from that function, I've got a function to update the bug grid. So this updates a single bug grid. Just probably add a comment in there. And what it does is it creates a new grid, just like the previous one, except now I'm going to pass in the bug grid and the depth, and then that is going to pass that down to count bugs, and pretty much do the same thing as the previous version. I also have a helper to generate a grid. I guess I could have used that there, but in any case, so I've got that. And then for update grid dictionary, that is going to loop through the dictionary. It's going to look at the max and minimum depth value and keep track of those. And then it is going to update each grid, make a new grid, and then assign that to its current depth. And then what it does is it looks at the max and min values, creates a blank grid of periods, creates a new depth value, so it's going to go up 1 and down 1 from the max and min. And then it's going to update from the current max and min. So it's going to look at, well, it's just going to call update grid on the new blank grid. So what that's going to do, because I've written my logic this way, is it's going to look one level below, and then because the outer level doesn't exist, if we're at the max, it's just going to ignore that. So that will compute a new max outer grid, so like grow a new grid of bugs from a blank one, and then that gets added into the new grid dictionary. So each iteration or each call to update grid dictionary creates a new dictionary and then populates that with new data and returns it. Then from there, last thing I do is count all the bugs. That is a pretty dang simple function. It's a triple nested for loop. It's going to loop over grids in the grid dictionary and each row in the grid, each character in the row. And for each character, if that is a hashtag, count one bug and then return the result. And that is it. So if we run this, see, it takes a minute. There we go. So 1,916 bugs after 200 minutes, which is the answer. So yeah, that's all I've got for day 24. This one was not really about data structures. It wasn't really, I guess it kind of was about algorithms. This was more of a logic puzzle than anything, and just being able to handle the massive amount of instructions that you're having to deal with in the puzzle. So like really following the directions very closely, paying really close attention to the example data that they give you, and just making sure that you've kind of dotted all your I's and crossed all your T's, and being able to reason about that recursive, like, growing list of grids of bugs. So there were some cool visualizations of this on Twitter flying around. It's not really, I don't want to say it's not possible, but it's not really easy to represent this recursively. So what I saw some people doing was just like growing the amount of grids and kind of displaying their changing states as time went on. I didn't really want to jump into that. I feel like I've done some really cool visualizations already with the mazes, and I'm kind of I'm feeling the burn from doing all these puzzles. So I really wanted to get to day 25, which is the finish line and a really cool int code problem. So definitely check that one out when I hopefully crack that one. But yeah, day 24, 48 stars so far. Feeling pretty good about it. Very salty about day 22 and just mad at myself for not being a mathematician, I guess. Somebody actually wrote an article about modular arithmetic for beginners. So I'm going to be digging into that a little bit, trying to brush up on some of that math, to try and prepare myself, I guess, for next year, or if I ever run into a problem like that again. From what I've heard, it's pretty useful for low-level programming, like, say, programming for hardware or stuff like that, or cryptography. So there's merit to it. It's just not something that I'm probably ever going to touch in my line of work. But yeah, thanks for joining me for day 24. Like, subscribe, review, all that good stuff. Leave a comment. Let me know how you're doing, and I will see you on day 25.